Hello guys, so in today's video I'm gonna cover 10 problems on the invariance chapter, so let's dive right in. The first problem, you have an 8 into 8 chessboard has opposite corners removed, which means either 2 white or either 2 black. So if you take 2 into 1, like 2 squares, it should be 1 white and 1 black. But there's a color imbalance, right? Either you're losing one full white thing or one full black tile. So you can't quite match up with the alternative fill up because you're losing two white or two black, not one white and one black. So you can never tile this like this. So that's just simple. Second one. Okay, this question I keep on emphasizing in almost every videos because this is the most important question in the invariance chapter. So just look at one thing. We have sum of first n integers is n into n plus 1 by 2. So sum of 4n minus 1 integers is 4n minus 1 into 4n minus 1 plus 1 by 2, which is 2n into 4n minus 2, which is it's just always even. Okay, so they gave only one number remains, so we can confirm that it's always the number is even as the sum is always even. And you gotta remember one thing. When you subtract 2 minus 1, so it's 1, 2 plus 1 is 3. So you take 3 and add 1, which means the sum of the sequence is reduced by 2. So it's always an even integer. It's always an even number, right? So the sum still always remains even. So ultimately, the last number must be even. So this one, the okay, yes. I'll keep on emphasizing this key inside. You remember, it's always plus or minus one per coin. But here you flip 3 coins, so you have plus or minus 3. So first, 0 heads, and you take plus 3, which means in the second step you take okay, let me explain this clearly. um okay First step equals 0 heads. Second, you take plus 3, and first step you take minus 2. That's because in the permutation parity changes and you have one tail coming in plus 3, so that's the plus 1 here. So here you take you actually lose 2 because this is plus 1 minus the 3 in the tails checker. So that's 1. If you look at this, not only third, like fourth, fifth, sixth, 1 minute. Oh, okay. So like that, the sequence continuously goes on. So it always occurs in an odd number. So in an even, they ask prove that you can end with exactly 1 heads in even number of steps. Then that's wrong. That's wrong because you can't quite do it in even steps. It's always odd. See, even sort is odd. Oh, wait a minute. So in odd number of steps, in any odd number of moves, you can have 1 head. Okay, swapping neighbors in the list. 1 to n, no order. First you take x and y, and then you completely reverse it up, so it creates one new order. And you take so x and y are swapped, right? Now you take that y as x and this x as y, and you again swap it. Then it always end up having the same. You keep on repeating the process. You can always return to the same state as start. So if it was even, it becomes odd. If it's odd, it becomes even. So every neighbor swap changes the count of out of order pairs by exactly 1. So order even always flips, right? So that's because you take consecutive integers in this one. So in 15 possible, okay, 15 possible. do that, read. Okay. Let me. What am I? Okay. So I prepared it here. 9, 10, 11, 12, 13, 14, 15, 16. I mean, no, let's leave it blank in here. This is 16. Um, so this space is empty when, even though if you change these number, the empty space cannot be stuffed in because it always has to be empty, which means when you swap these numbers, the permutation parity changes, which means ultimately the exact property of this sequence changes. So you can't quite reverse if you swap it. You can reach every possible arrangement. So this is not possible. Okay, walking on a grid, can you return? Okay. Okay, they're asking an odd number of steps. Now this is quite simple. You go one step forward. The minimum number of steps you take to come backward is one, and the maximum is one as well. So you take two steps. You again take two steps. So total number of steps is always even. So you can't quite end with. I mean, you can't quite return with odd number of steps. It always has to be even because you take odd in front, you take odd in back. You take even in front, you take even in back. Odd plus odd is even. Even plus even is. So, yeah, even plus even is even, right? So you have two numbers A and B. Okay, this is. Wait a minute. Let me teach you this. So you take these. Yesterday I told you, right? Oh, come on. So 48 and 18, you take 48 minus 18, which is 30, and then it's 18 in here, just substitute the same thing. And 30 minus 18 is 12, and then it's just 18 here. You know why it's 18 here? The left side should always be bigger, and the right side should always be smaller. That's not for MCQ questions. If you have to write the answers, you have to write greater in the left hand side and lesser in right hand side. So finally, if you look at GCD is nothing but the greatest common divisor. We can clearly see that in all of these, the greatest common divisor is always 6. So the GCD never changes when you do these steps. See, you replacing the bigger one with the difference proof the GCD never. So that's just it. Uh, I suggest you to maintain one single note for this IMO because I don't want you to be orthodox like reading whole books. You just need some important formulas. Again, the other formulas can be derived using logic. Okay, now this is a kindergarten level question. I deeply criticize these type of questions. Okay, so you just have the number. You take any integer. Okay, you take 13 divided by 2 is 6, and then 3, and then 1 it completely becomes 0. You know why it's 6 and not 6.5? They said gobble up, drop drop the remainder. So gobble up the point, the decimals. So that's called the greatest integer factor, or GIF, where you just gobble up the decimals. And for example, if it's 6.8, you write 6 because 6 is lesser than 6.8. And if it's negative, for example, you take minus 1.5, you write minus 2. That's because minus 2 is lesser than minus 1.5. You just gobble up the decimal and write the near smaller integer to that number given. So the ninth question, okay, in any network. Okay, this is again a kindergarten level question if you know how to apply logic. So, think of some examples. Two roads being connected, or two people being connected with a friendship. With friendship. So, in the case of roads, you have one connection for two roads. So, even with one connection, you have two roads, right? So, even if the number of connections is odd, the number of nodes is even. So, the number of roads is the nodes. And if you take the friendship, two people are connected in one single, uh, thing called friendship. Uh, one connection but two nodes, two people. So that's the point of all these. So it's always, always, always coming, like, comes in pair. So it's always even. So this is the last question. Okay, now this is let me explain. This is simple again. IMO questions are not that difficult. They just need different type of thinking. Okay, let me start. So they said start with 0. You can either add 5, so plus 5, or minus 3. Okay, so first of all, you just add 5 because they want 1. So first of all, you just add 5. 0 plus 5 is 5. If you do 5 divided by 3, the remainder is 2. So you again follow the step. You again follow, add up 5. And 10 divided by 3 has a remainder of 1. Which means when you keep on subtracting 3, it has to end up with 1. So 10 minus 3 is 7, and then 4, and then 1 eventually. So that's it. The question is solved. Yes, it can be reached. It can always be reached by, you know, uh, adding 5 or removing 3. Okay, let's just check quick summary. Just take a screenshot. You can just search in Google or ChatGPT for more questions, like more type of questions in these. So these are the famous type of questions in IMO. So you can just take a screenshot and just copy paste in ChatGPT and ask more problems on these concepts. So that's just pretty simple, not that tough, right? Just logic. So that's it for today, guys. Stay tuned for the link for my math club so that we can build our future using math plus AI plus, some stuff. So like and subscribe to my channel. Bye, guys. See you tomorrow.